What is it?
Friction.
Why do we slip when we step on a banana peel?
Because
It's slippery.
like it's uh,
Have you ever thought, why is it difficult to walk on a smooth and wet floor? Why does a rolling ball stops after some time? Why is it easier to move a box when it is already in motion and much harder to move it if the box is at rest? So the reason behind this is frictional force. When two surfaces are in contact with each other, then their irregularities get interlocked, and due to the interlocking in irregularities, frictional force arises. Friction arises. So frictional force is defined as an opposing force. Opposing force means it always opposes the direction of motion. If the object is moving in this direction, then frictional force will act in the opposite direction. Okay?
uh, hmm.
It is the opposing force that comes into play when one body moves or even tries to move over the surface of another body. So when one object tries to move over the surface of another object, then it arises. Then frictional force comes into play.
Come.
Okay.
Yeah. Hmm.
As you can see here, this man is pushing this block. Okay. And frictional force is acting in the direction opposite to the direction of applied force. It always acts in
Okay.
the direction opposite to the direction of applied force. What is the cause of friction? What is the reason behind friction? Why does this frictional force arise? The force of friction arises due to the irregularities between the surfaces at contact. Look at my hands. Consider my hands as two surfaces. Okay?
Hmm.
No surface is perfectly smooth. No surface
Yes.
is perfectly smooth. There are irregularities. If you find the surface smooth by touching the surface, even then there are irregularities which can be seen by microscope.
Microscope.
So there are microscopic irregularities as well. Sometimes we find the surface smooth, but it is not perfectly smooth. There are irregularities which can be seen by microscope. Okay, so
Yes.
if we have these two surfaces and they are in contact with each other. As I had said that no surface is perfectly smooth. So there are irregularities on the surface like this. You can see this. These are the
Hmm.
irregularities you can consider. So these irregularities get interlocked. So these are two surfaces. This is first surface and this is second surface. So irregularities get interlocked. So when we
Okay.
try to move one surface over the other, when we try to move one surface over the other, so these irregularities, we need to break these irregularities. Only then this object can be moved over the surface of another object.
Okay.
Okay. So we need to break
Hmm.
the irregularities. So some force is required to break these irregularities. So if we apply sufficient force to break the irregularities, then the object moves. Otherwise, it won't move. Okay.
Hmm.
So we have an activity here. Friction opposes the relative motion. Relative motion means, the word relative means when one object moves over the surface of another object. So here we are considering the positions of both the objects. Okay, motion is a relative term. We say that nothing is in absolute rest or in absolute motion. It is a relative term. Okay,
Yes.
as you can see that if you are sitting here in the room and for me you are at rest, but for
Hmm.
someone who is observing you from the moon, he'll find you moving because Earth is rotating about its axis, so you are moving along with the Earth. Right? It is a
Yes.
relative term. It depends upon the position of observer and the object under study. Now, in this activity, we will talk about that how this friction opposes the relative motion. So gently push a book on a table. It stops after moving for some distance. Repeat this activity pushing the book from the opposite direction. What do you observe? So we have a book on the table and we apply force on the book and it moves in certain direction. And then we stop and apply force in the opposite direction. Then what do you observe? If force is applied along the left direction, friction acts along the right direction. If we apply force towards the left direction, then frictional force will arise towards the right direction, opposite to the direction of motion. Okay.
Motion.
But if we apply force along the right direction, then frictional force acts along the left direction, again opposite to the direction of motion. So it always opposes the direction of motion. Direction in which the object is moving, frictional force acts opposite to that direction. Okay.
Yes.
So the force of friction always opposes the applied force. It will always oppose the motion of the book, as in this case. Okay. Now, friction arises due to irregularities. The irregularities on the two surfaces interlock into one another. These interlocking try to stop an object when an attempt is made to move any object on the surface. A force has to be applied to overcome the interlocking. So we need to apply force to overcome the interlocking, as I had discussed already, that no surface is perfectly smooth. So there are irregularities on the surface. When one object is placed on a surface, then surface of the object and the second surface, their irregularities get interlocked like this, and we need to apply force to break the irregularities. Only then the object moves. If number of irregularities on the surface is greater, then force of friction is also greater. Okay. If we have more irregularities, then more force is required to move it, because force of friction is also greater. At times, the surface that appear to be smooth also have minute irregularities, small irregularities. So there is no surface that is absolutely frictionless. So we can say here, it means that no surface is perfectly smooth. Perfectly smooth means that there is no friction. Perfectly smooth means that there is no friction. No surface is perfectly smooth or frictionless. So there are minute irregularities on the surface. Okay.
Yes.
Should I move to the next slide?
Yes.
Now we have another activity. Greater irregularities implies greater friction between the surfaces in contact. Tie a string around a brick. Pull the brick by a spring balance by applying force. Note down the reading of the spring balance when the brick just begins to move. So we have a spring balance here, and you can see this red brick, and this spring balance is attached to this red brick by a string. Okay. Now we are pulling
Yes.
the brick by the spring balance by applying force. We are applying force in this direction to move the brick. And we will note the reading in the spring balance when the brick just begins to move. Okay. It gives the measure of force of friction between the surface of the brick and the floor. So in this way, we can find the force of friction between the brick and the floor. Okay. Repeat this
Yes.
activity by wrapping a piece of jute bag around the brick. What difference do you observe? In the first case, brick is in contact with the ground. Is rough. In the second case, when the brick is wrapped with polythene, the surface gets smoother. Hence, less frictional force is required to move it. By wrapping a piece of jute bag, friction increases. Reading of the spring balance is more. Because jute bag is rough.
Yes.
More friction and more force is required to move it. And polythene is soft, smoother as compared
Yes.
to jute bag, and therefore there will be less irregularities, and so is the frictional force. We can perform this activity in the class. It can be done. I have a spring balance. I'll show you one day. Okay.
Yes.
Now we have another activity. Greater irregularities imply greater friction between the surfaces in contact. It is based on this. Look at this. Mark an inclined plane by wooden board. Mark a point A on the inclined plane. See, you can see that we have a wooden board here and we have marked a point A on the inclined plane. This is point A. Now let a pencil move down from that point. Okay, we'll slide, roll the pencil. Okay, let a pencil move down from this point. How far does it move on the table before coming to rest? Note down the distance. Now repeat this activity by spreading a piece of cloth. You can see we have a piece of cloth here over the table and by spreading a thin layer of sand over the table. In which case is the distance covered the minimum? Why is the distance covered by the pencil different every time? Now give me the answer. So we have a wooden board. We have kept it inclined. And now we have a pencil here. Pencil is moved down. Okay. And it covers some horizontal distance. In the first case, we had placed nothing here on the table. But in the second case, we have spread a piece of cloth or we can spread a thin layer of sand over the table. So in which case the distance covered would be the minimum? Now tell me the answer.
In the B.
In case B. Why in case B distance covered is minimum?
Because the sand is more rough or a piece of cloth.
Okay. And what, when we had placed nothing then what?
Placed nothing, then the pencil will move faster.
Will move faster because there is less friction
Yes.
and it will cover more distance.
Hmm.
So the distance covered by pencil is different every time because of the different amount of friction by different surfaces. The distance covered in the case of sand is the least as this surface provides the maximum friction. Sand provides the maximum friction and therefore pencil will cover the less distance, cover the minimum distance. Okay.
I've read.
Okay. So factors on which friction depends. First, we have nature of the surfaces. How does friction depend on the nature of surfaces in contact?
When the when there's a rough surfaces
Hmm.
like sand or jute bag, there is more irregularities and more friction will be produced and uh, and if we have a smooth surface like a polythene or any other object, then there will be less friction.
Yes. So rough surfaces have more irregularities resulting in interlocking, more interlocking and hence more friction. Similarly, smooth surfaces have less friction. Next, we have weight. See, it is difficult to move heavier object as compared to lighter object, right?
Hmm.
The more the weight, more is the friction because when two surfaces are pressed against each other harder, it
There
results
are
in
more
tight,
interlockings.
yes, it results in tight interlocking. So we need to put more effort to move it, to break the interlock.
Yes.
Yes?
Hmm.
A ball rolling on the ground stops after some time. Why does the ball stops after some time? Please unmute yourself.
The ball rolling on the ground stops after some time because friction, because of opposite uh, friction. The
Yes, because
like
frictional force comes into play which acts in the opposite direction.
yes.
Yes, due to friction between the rolling ball and the ground, it stops after some time. The force of friction always opposes the relative motion. Second, it is difficult to walk on a soapy floor.
Soapy floor is soft, smoother. That's why when we walk on a soapy floor, it is difficult to grip uh, to uh, to make grip on the floor, on the
No,
soapy floor,
yes, because it is
because
smoother, it has less irregularities. Soapy
yes,
water reduces the friction and the foot cannot make a proper grip on the floor.
floor.
Next question. It is easier to push a lighter box than to push a similar heavier box on the same floor.
It is uh, because a heavier box,
Mhm.
because heavier uh, box it's very heavy, so there is more irregularities, and the flow
In case of
and
heavier
the
box, see friction.
irregularities
We
between
have done. Yes.
heavier box and the surface uh, get locked tightly, and that's why it is difficult to move a heavier box.
The heavier the object, the more friction is applied, thus making it difficult to push a heavier box. Though the surface floor is the same, but it is difficult to push a similar heavier box because it is heavy. So both the surfaces get pressed against each other and they are stronger interlockings.
Yes.
And we need to put so much effort to break the interlockings.
Hmm.
Painters use sandpaper before polishing doors. Have you seen painters? They have sandpaper in their hand and they rub the walls and the doors before polishing and painting.
So that there will be more tight interlockings.
Interlockings, or they create roughness on the wall.
Yes, rough. Yes, because the sandpaper is rough.
Sandpaper, when we rub the sandpaper with the wall, it makes the walls rough.
Wall rough. Yes.
Yes. So painters rub the sandpaper on the wall and on the door for increasing the roughness of the surface of the wall and the door. When roughness increases, then force of friction increases, thus adhesive force also increases.
Hmm.
Okay.
Yes.
Next, so we have these questions for homework. Please take the screenshot. You are supposed to write the answers at home.
Taken.
Good. Should I move to the next slide?
Yes.
So there are three types of friction. First is static friction. The word static means rest. What is the meaning of the word static?
Rest.
Rest. So when two objects are in contact with each other and the objects are at rest, there is nothing moving, then we say that the between the surfaces there is static friction.
Hmm.
Okay. And sliding friction. Now, what do you think of sliding friction?
Sliding friction like wheels.
Wheels roll on the ground. No?
Oh.
Sliding friction,
Sliding
something like this.
like
When we slide this is sliding. Sliding.
okay.
So when one object slides over the surface of another, then the
Then
frictional
it's
force which
sliding
arises
friction.
is called sliding friction.
Sliding friction.
The third one is rolling friction. What is rolling
This
friction?
one, uh, rolling friction means
Look at this.
wheel.
It is rolling. Yes.
Okay.
This
Yeah.
kind of friction is rolling friction.
Like wheels too.
Yes. When frictional force arises when the object rolls over the surface of another object, then there is rolling friction.
Hmm.
Okay.
Yes.
So first we have static friction. So when two objects are at rest and they are in contact with each other, then static friction exists between them. In this case, you can see that this object, this block is lying on the floor and there is no motion in the block. It is just lying on the floor. So there is static friction and gravity is acting in the downward direction and this normal force is acting in the upward direction, which balances the gravity. And the frictional force, you can see this arrow, the red colored arrow, it shows the force of friction. And there is no motion at all. In case of sliding friction, when one object slides over the surface of another object, then resistance to its motion is called sliding friction. Sliding is something like this. When one object slides, you look at my hand, like this.
Yes.
When one object slides over the surface of another object, then resistance means obstruction. The word resistance means obstruction to power, to its motion is called sliding friction. So when it starts moving, then you can see that it is sliding over the surface of another object. So this force is it comes into play. We are applying this force in this direction and frictional force is acting in opposite direction. Object is moving along the direction which the force has been applied. Okay, object is moving in the direction where we have applied the force. Next, we have rolling friction. So when one object rolls over the surface of another object, the resistance to its motion is called rolling friction. When it rolls over the surface of an object, like this,
Yes.
then it is called rolling friction.
Friction.
Now look at this. Here in this particular case, you can see the area of contact. Area of contact means where the area where the two surfaces are touching each other. This area is less as compared to this area.
Yes.
This area is greater.
Yes.
And this area is less. Right? And here, when the object rolls over the surface of another object, then new interlockings get formed, which need to be broken. So you can see that when it rolls, then the object gets less time for interlocking. Object gets less time for interlocking. Yes?
Yes.
Now we have static friction is greater than sliding friction. Why is static friction greater than sliding friction? What do you think?
Greater. Like what's?
Suppose we have these two cases. First is the case of static friction. You can see here, look at the cursor. And this is the case of sliding friction. Both the objects are the same, surfaces are the same. Still, we are saying that sliding friction is less as compared to static friction. Objects are same, surface is same. Then what is the difference? Why is sliding friction less?
No motion.
Because no motion, and this is the reason that static friction is greater. Yes, it is not moving.
And there's no force produced.
See, when in static friction, two surfaces are at rest with respect to each other. The irregularities are completely locked in. So friction is higher. But in sliding friction, one surface slides over the other. The irregularities do not get time to interlock. Hence, sliding friction is always less than static friction. Because irregularities do not get time to get interlocked, as one surface is moving over the another surface. One object is moving over the surface, now it is moving. So there is less time for the irregularities to get interlocked. But when it is kept on the surface, then it has more time to get interlocked.
Yes.
Okay, and this is the reason because their irregularities are completely locked in static friction. Irregularities are completely locked in and therefore it is greater. On the other hand, in sliding friction, irregularities are not completely locked in and therefore it is smaller. Okay.
Yes.
Example, it is easier to move a box when it is already in motion and much harder to move it if the box is at rest. If the box is at rest, then we find it harder to move it. But if the box is moving, then it is easier to move it further.
Yes.
So when the box starts to slide, the contact points do not get enough time to interlock with the contact points on the floor. Therefore, sliding friction is less than static friction. Easy?
Yes.
Next, we have sliding friction is greater than rolling friction. Sliding friction is less than static friction and greater than rolling friction.
Because rolling friction has less time to interlock.
Yes. Place few
Because
pencils parallel to each other. We have an activity to prove it. We'll place few pencils parallel to each other on a table. Now place a thick book over the pencil and push the book. You observe that pencils rolling as the book moves. Do you feel it easier to move the book in this way than to slide it?
yes.
Which one is easier? Simply sliding the book on the table or keeping the pencils under the book and then rolling it?
Uh, Keeping simply sliding.
Keeping the pencils is easier.
Like it can, the book can go more far.
Yes.
Yes, because there's less time to interlock with
Yes.
the surface.
It is observed that book moves efficiently when placed on cylindrical pencils or rollers. It can be concluded that rolling friction is smaller than static or sliding friction. Okay.
Yes.
Now let's recapitulate whatever we had done so far. What is force of friction?
Force of friction is that in the direction we are pushing the box, or anything, the force of friction will be opposite to him. Uh,
Mhm. Force of friction arises due to the
Rises due to the
regularities
irregularities between two objects
and it comes into play when one object moves or even tries to move over the surface of another object. And it is always equal and opposite to the direction in which the force is applied. Okay. Suppose we are applying force in this direction, then frictional force will act in the opposite direction.
direction.
Next question. What is the cause of friction?
Cause of friction is irregularities between uh, two objects
Yes, irregularities get interlocked.
interlocked.
Irregularities between the two surfaces in contact, they get interlocked. Is
Mm,
the friction same for all objects?
no.
No, friction is different for different objects. It depends upon the nature of the surfaces, nature of the object. Why are wheels of vehicles made circular?
Uh, Wheels of vehicles made circular because of rolling friction, uh, like uh, uh, it's because they're interlockings, because they have less interlockings.
Yes, because rolling friction is less than sliding friction and therefore they are made circular. Next question. What is the direction of frictional force on a moving object?
What is the direction? Opposite direction.
Hmm. Opposite to the direction of motion. Next question. When does static friction come into play?
When a box is at rest, is moved, like
Static
when
friction comes into play when one object
is at rest.
Is at rest over the surface. It is about to move. It is not moving. When one object
Yes.
is at rest, then
Then the static friction
static
takes
friction
place.
comes in. Yes. Next question. What are the factors on which frictional force depends?
On which frictional force depends. That frictional force is in the opposite direction.
No factors. Here we are not talking about the direction of the frictional force in which it is acting. We are talking
Uh,
about the factors.
Factors are irregularities.
The nature of the surfaces, we can say,
Yes.
and the weight. Yes. So what are the factors on which frictional force depends?
Nature of surfaces and weight.
Nature of the surfaces and weight. What is a measure of static friction?
When a static friction is at rest,
Mhm.
uh,
Measure of static
and,
friction.
and
The force required to overcome friction at an instant object starts moving from rest. How much force is required to move it? Yes.
mm,
Next question. What is a measure of sliding friction?
uh, when object is moving,
It is sliding over
uh,
the surface of another
yes. So
object.
it uh,
The force required to keep the object moving with the same speed. The force required to keep the object moving with the same speed. How much force is required to keep the object moving with a constant speed is the sliding friction. Next question. Why is it easier to move the box already in motion than to get it started?
uh, why is it easier to move the box already in the motion than to get it? Because when because if the box is moving, then less force is uh, produced. Well, and
If the box is
if
moving, then there is
is
less
it
friction.
the box at rest,
Mhm.
then they are they are uh,
Sliding friction
they
is
are
smaller than
they are interlocked. They are locked tightly. That's why we need to. It is difficult to move a box at rest.
because interlockings are completely locked. When the box is at rest, then interlockings are completely, irregularities are completely interlocked. But when the
Yes.
box is already moving, then it has less time for interlocking. Okay.
Mm.
What is a spring balance?
Spring balance is to measure the uh, gram weight. Gram weight.
It is used to measure force in gram weight. Yes.
Yes.
Next, we have another tutorial. Please take the screenshot. You're supposed to do these questions in your assignment notebook.